So like we said, this is really casual. It's a place for everyone who's part of PEP or interested in joining the PEP session to just have discussions, ask questions, answer questions, for any newcomers who are interested in the session to, you know, ask their questions and really see what the PEP session is all about.
Great opportunity for us, I think, to ask our questions and learn about the section.
Sorry, my volume was down. I didn't hear that.
Okay. A great opportunity for us, I think. I have been to choice course and it was really awesome. And now I may ask some additional questions.
Oh, yeah, this is like a great place for that.
That's great. I don't know if you could hear me. This was Jim K. I don't, do I have my microphone muted? Oh, okay.
I can hear you.
Oh, hi. I just wanted to make sure everybody knew I was on.
Yes, thank you. Jim has agreed to be one of our hosts for the PEP session.
All right, why don't we go ahead and get started. I want to welcome all the guests that have logged in for the annual meeting. And what we're going to do is hold our usual monthly team meeting, but we're going to switch the agenda around a little bit. We've divided our Bright Star Monitor team into 5 groups, as you can see from the agenda. The science branch, the technical branch, software engineering, and business development. And I think the whole concept here, and this is really the brainchild of Arnie, is to develop a network of small telescopes to look at the brighter stars in the sky that are easily overlooked by the bigger telescopes, and show that we can do good science with this. And it reminds me many years ago when I was advised in terms of
Oops, seems like the audio went away.
I don't hear anybody.
Yeah. This is Jim K. Can you hear me?
Yeah, Jim, this is Jack Chernowski.
Hi.
Hi, I took your course. I have to travel to pick my wife up, so I'm doing this from the car. So,
Okay. Well, be careful.
I am. I'm on Bluetooth, so I'm fine right now.
All right. As long as you're safe, we certainly wouldn't want any. Yeah. Yeah. So this meeting really is about any questions you might have, and then you know, I can go over some generalities, some of the targets. I think Tom Caldwell's going to join as well, and he'll go over some of that as well. Really open for questions first, just to see what people may have on their minds. And then if not, I'm happy to pull up a presentation and kind of walk through what we talked about, say, at our last quarterly meeting. We, as a group, we tend to meet every quarter via either Zoom or Skype, usually Skype. And I thought I could give a flavor for any of the people that maybe didn't join, you know, who haven't yet really joined the PEP observing group, just so that they can see kind of what we cover. But I'm very open to questions first. So hopefully people are able to unmute their microphones if they have questions, and I'll open it up for anything people might want to say.
This is Greg Donahue. I'm just saying I'm totally brand new. I'm just joining to find out what it's all about. So don't have any particular questions at this point.
Okay. Well, anyone else?
I have a question. Sorry.
Did I cut somebody off? When you're trying to get the coefficient, the transformation coefficient for your equipment, right now I'm trying to use the stars that Tom recommended in Pegasus. Unfortunately, I
about 7 or 8 readings about a week and a half ago, and I realized my numbers were going crazy because my dew shield wasn't working right. So I had all kinds of so I had to quit. But anyway, we're also supposed to get stars for extinction, right? The different air masses.
Yeah.
When we're doing that, okay.
Well, when the intent when you do the transformation coefficients, we've tried to pick the pairs, the red-blue pairs, to be fairly close to each other in the sky,
Right.
and so and we try to observe them as high as we can in the sky, to try to make the extinction corrections as small as possible. But ideally, you would also get extinction corrections at the same time using either the Hardy method, where we would measure some number of stars, or and calculate the extinction based on that, which is about a 15-minute to half an hour observing run in PEP, or if not, you can kind of follow a star over a longer period in the night. Most people, when they do their first transformation coefficients, if they've made the measurements and picked the times so that the stars are fairly high in the sky, since the stars are close together, the extinction coefficients and the extinction corrections are about the same. So I would say, John, for your first go around, if you don't do extinction, that's probably the best thing. I think that would be simpler. That's what most people do, and it seems to work pretty well. So let's keep it simple first time around, and then if you get to a point where you want to, go for the gusto, we can talk about the extinction. But let's just stick to the regular observing, and you should be fine.
Yeah, that sounds good. I do have one question though. I took it out of Arnie's book that he wrote. I can't remember the title of the book. Chuck and anyway, in the appendices, it gives you a list of stars for first order extinction. I've noticed some of those stars are listed as variable stars.
Well, if they are, as long as they're longer period variable, you'd be okay for extinction. They're picked mainly so that they're, I believe, spectral type A0, so that then when we do the extinction, we don't have color effects, so that typically the extinction stars are like the A0 type. Yeah, so it is interesting. Now if they are more rapidly varying stars, where you'd see something over the period of a night, then that's a problem. But if they're longer term variables, it probably wouldn't matter over the period you're measuring. But my own take, why pick those ones unless there's some compelling reason?
Yeah. I was going to cross check them with the Aavso website, see if they were still listed as variables too. But that's not a problem because there's a lot to choose from. So
yeah.
Okay.
Yeah, it's works pretty well. Yeah, so I'd be interested. Certainly send Tom the information. He can help you out with the transformation calculations. It's kind of nice the first time you're through to have somebody look over your shoulder, and we're happy.
Yeah, absolutely. That's my plan.
Do that. And if you go to the website too, there's also a web page that goes over that. If you go to the red blue pair web page, I'm not sure if you've done that. Yeah, you already been there. Okay, great. Then you're all set then.
Okay.
But yeah, we absolutely love to transform, because I talked to Tom last night, and PEP data is not about throughput or high volume, right? We don't do in general a whole bunch of stars. We're not like the technology doesn't allow that, right? You basically have to spend a fair amount of time. So because of that, and you put so much effort into getting that data for that one star, we really like to drive to high accuracy. It's kind of almost like a challenge, right? And so we definitely want people to take the time to get their their transformation coefficients. If you're going to do PEP, you definitely want to transform data. It just it's what you want to do for sure.
Perfect.
So good luck with that, and please keep in touch. My take on it is the hardest thing is finding a night in Vermont good enough to do the transformation measurement.
I have the same problem in Maryland. I have
Yeah.
it's been amazing lately.
Yeah. So I
Amazingly lousy.
hear you on that. All right. Well, let's see. I see Frank's on. John just talked. Michael. Yeah. Well, I'm open to other questions. Certainly also happy to show some material, but I prefer it if people just kind of pepper me with questions, and if not, I might ask you some.
Okay, then I will take the first. I haven't received my SSP device yet. Hopefully next week. I'm from Turkey. And I want to ask, does a computer really helps while taking the data? Or should we, I mean, I haven't done anything yet, but or should we do all the stuff manually?
Okay, so do you know if the SSP you're receiving is either Gen 1 or Gen 2?
Gen 2.
Okay, so it could connect to the computer.
Okay.
It's not necessary to connect to the computer. Okay, so what that does, of course, is prevent you making any mistakes when you transcribe the data. It's also nice because if you have reasonable tracking on your mount, it will take all the integrations, like the 3 10-second integrations, for you continuously. And so it takes a little bit of a load off you as an observer. But if you're just starting out and you want to get up and you want to get your first observation in, it is absolutely really easy to use it in a fully manual mode. And you just put it on your scope, line it up, flip the mirror after you've aligned the star, and then take your 10-second integrations. So again, on the idea of maybe keeping it simpler first, maybe your first observation just do manually. And then after that, hook it up. The computer control is going to be really just to take the readings. You're still going to have to slew the scope, center the star. So you're still in PEP going to pretty much do all that manually. Although you may have a go-to mount, so it'll slew to the star for you, but you're still going to have to line it up in the center of that reticle. So
okay.
I think I would recommend maybe do the first one manually.
Yeah, sure.
Because it's just less, well, because it's easier, right? Make it easier first and then add the other complexity later on.
Okay. And one more question. In the choice course, we talked about data reduction programs, but we didn't, use it in the course. Which one do you suggest, or should we use the Excel file in that course?
I would say we do have an Excel file from one of our observers in the Netherlands, Erwin, that I believe Tom has posted. If not, if you send him a note, he can give you a link to it. I don't have that link right in front of me now.
Okay.
But then you can use that spreadsheet directly. The other thing I'd recommend on your first observation is to also send the raw data either to Tom or to myself. And we can also reduce it and compare your first reading, with your reduction and make sure it's right and walk you through so that the data reduction, we want to get to where the data reduction just becomes push a button, get a banana, right? Rather than having to do a lot of work. So the first couple, go ahead, take the data. We'll also get you that spreadsheet and Tom a note. I know he also has written a Python program, which he's been open to share as well. So any of those are ways we can help you out for the first observation.
Okay, thank you.
So, okay. Any other questions? No questions. All right. Let's see. I think what I can certainly do is see about sharing some of the things from our last talk. So I'll open that up and I will see if I can share my screen, see if people can see that. Hold on just a second. Oops. No, you're not there. All right. Okay. So I'm going to go ahead and share my screen and we'll see if this works. Can everybody still hear me? Okay. I think that was a yes. I saw that. Okay. So I'm going to go ahead and share my screen here. Just bear with me a minute and see if I can get this to work. All right, that's good. And I am having some, all right, here we go. Okay. I'm having trouble. It's popping me back out. Okay, here we go. Let's see. Now, if I did that correctly, you should be able to see the PEP Telecon from October. All right, thumbs up. Okay, good. And I'm really showing you this for those that haven't joined. Drop Tom a note and he'll get you on the PEP talk list. And we do these about every 3 months. And it gives us a chance to share what we've done as observers. Tom does a great job of going through what the target stars are. You're obviously encouraged to follow your own interests in terms of stars, but a lot of times we'll have campaigns or we'll have some need for a particular star that a professional has asked about. So we also communicate those through that as well. And if you haven't read the AAVSO newsletter, you'll see that when that comes out, there's always a PEP section as well. So let me go ahead and some of you have been to these, so you've seen this. In fact, I think anybody on the list, I think Michael, maybe you haven't been to these yet. So
yeah, that's right. I haven't. I also missed the PEP course, the choice course, unfortunately, but hopefully I can get in on the next choice course.
So, well, I'll go ahead and I'm going to go through this. For some of you, it's a little bit of a repeat. And it's not so much to communicate specific information right now as to just give you a flavor of it. So let's go ahead and do that. Wow, I'm having a little trouble clicking today. Yeah, so in the third quarter, 780 observations. Most of you may know of Jerry Persha. He's the inventor of the SSP. So since he invented it, he's also managed to automate it as well. So his observations tend to be automated. And he has a lot of observations, time series, things like that. And then congrats to the other observers listed as well for their observations. And a mix of both new and long-term observers. So that was good. So I was, that was kind of pleasing. So.
Can I say something? Hi,
yeah.
everyone. This is Stella. What did you think of the presentation yesterday on an exoplanet transit with PEP?
Oops. I did not go to it, so I'll let others comment.
I am new in PEP, but I didn't know that it can be done. So it was a shock to me. Well, it's nice to see, and it's nice to realize that people can do with PEP. It's great.
Yeah, it was a young person who actually gave that presentation, and the way that they did it was, oh, you're gonna love this. They had a telescope and a PEP Photoelectric photometry attached to it, and they did it as a public outreach thing. So they had the telescope outside, people were coming through, and they would show as the transit was happening real time. I was so impressed. I was really impressed.
I'm sorry, I missed that.
Oh, it's going to be recorded. You'll see it. But it's,
All right.
yeah. I just wanted to stop by and say hi. Sorry for the interruption, but it's good to see you and meet some of you. I haven't met you in person yet.
It's always nice to see you as well, Stella.
Yeah. I'm going to jump around, so I may come back as well. I'm rotating.
Okay. All right. So we may see you then.
Keep up.
All right.
Keep up the good work.
All right.
Just want to see the people you talk about.
Okay.
Hi, it's me.
That's my wife, Jane. She's saying hi.
Jane.
So that's great. All right. So yeah. So we have certainly long-term observers. We have some people that have just started. Again, we focus on, as I think most of you know, bright stars just because of the nature of the technology, but also on accuracy. I may show a little later in this comparison that Tom and I did on accuracy a few years ago, where we actually were able to, I was in Vermont, he was in Oregon, independently making measurements to within just a few millimags, like, 3 or so millimags difference after data reduction. We had different transformation coefficients, different extinctions. Vermont and Oregon are different. But still, that's the level of accuracy you can get with this simple instrument on your telescope. So the idea of this, the whole nice thing about it is that we may only do a few observations, but we can do really high accuracy. And so what we want to do is pick our parameter space for PEP. And by parameter space, I mean, what is it that we have that other sections or professionals don't do? And to start with, it's bright stars. So for bright stars, for a typical PEP setup, if we're using SSP3s, you're probably going to keep it under 8th magnitude, if you have like a 12 or 14-inch scope. And even maybe less than that. You might do a lot of your work at like 6 and 7 magnitude stars. So that's nice in the sense that there's a lot of degrees of freedom. It's kind of nice to narrow the targets down so that you kind of know what to pick. And we'll get to this in a little bit. With all the recent interest on Betelgeuse, PEP was perfect for high accuracy measurements of that star. So obviously it's a bright star. We all know that. So very bright star. Fits right into our parameter space. It's a long-term variable. That also does. You can certainly do time series with PEP, but those that have taken observations know that it takes you about 15 minutes for one star, right? And that's once you get the technique down. So if it's about 15 minutes for a star, taking these really rapid time series type observations isn't really where PEP is the strongest. It's really stronger for a star that you're going to observe maybe once or twice. In a given night, you're probably only going to observe it once, maybe twice, as opposed to some of the other technologies. All right, so let's see if I can get to the next page. Some of you I know went into choice class, so and I have to say I hadn't graded quiz 2 yet. That's why there's holdups on your certificates. So that's my bad. I got behind on a couple other things, but I'm looking at them this weekend. Very interesting. Really appreciated all the comments. I think there's a lot we can do to improve that course. So don't hesitate to take it again if you've taken it. And if you haven't taken it, I believe it will probably be offered, but in a year or so. But if in the interim you're interested, I would point you towards the PEP Observer's Manual. The PEP Observer's Manual is online. You can find it right on the AAVSO website. And as soon as you get to it, you'll see that it's a very readable manual. Tom Calderwood did a great job writing that. Many of you have read either Arnie Hendens and I always have trouble pronouncing his name, Kajcek. Their book, it's a classic. Highly recommend it. It is absolutely authoritative. It has everything you need to know to get started, and even a little more. But I know some people may find parts of it just a little intimidating. And I think what Tom's done is made a very accessible version to get you started on PEP if you have any questions. And I think those in the class, I'll just ask for comments now. What did you think of the manual? Did you have any thoughts on, you know, we're always looking to improve it. So if you had any areas that you felt could be improved, let me know. What, anybody want to offer any opinion on that?
Well, this is Jack. I had I guess I still come away a little bit with a question on dark counts.
Okay.
Because I purchased the SSP3 first generation that was loaned to me, and I just purchased it like a couple of weeks ago. And I know you have to set the time to 1 second, and I think it was what, 1 second, and I can't remember the other number.
Yeah, normally you're going to set the gain to 10 and the integration to 10, probably both to 10 for most observations.
Yeah, but for the dark counts, I thought the manual says to set it for 1 second and 10.
Yeah, no, for the dark counts, what we do for our standard observing technique, we leave the gain and the integration at exactly the same setting for all the measurements. If the manual said to do that, I'll take a look at the manual to see. I'm not sure if they're doing that more as a test or a checkout. But in your normal observation runs, you're going to want to leave the, usually we standardize pretty much on 10-second integration, so set that to 10. Right. The gain, you're going to pick whatever gain's appropriate for the star. In my case, it's almost always 10, just based on the stars I pick and kind of the signal to noise ratio I'm trying to achieve. You might find on a really bright star, you might set it to 1. But
what's an appropriate number of dark counts? That's really where I'm, because the manual I got said like 5.
Well, okay, so
yeah. Go ahead. I'm sorry.
No, that's a great question. There's two things that contribute to the dark counts. One is the offset in the electronics. Okay, so that's totally independent of the sky. And then the other is the actual sky brightness. Right. And so, you know, depending on what your electronic offset is, who knows? I tend to get dark counts when I use a gain of 10 and an integration of 10. It's not unusual for me to get dark counts in the 200 range.
Okay.
You may get less, but as long as it's stable, you're all right. If it's in that range, and you want it to be, you know, within a few counts each time you do it.
Right.
If it's not, usually that means your sky conditions are changing, and obviously we like it when our sky conditions don't change, but we don't get to choose.
Yeah.
I will say once when I've tried to push things and do it as it's getting closer to dawn, the sky's actually visibly brightening, then obviously I'll see a systematic change in the dark counts. Then I know I'm pushing it and that observation might be a little questionable.
Gotcha.
But yeah. All right. So yeah, one of the issues with PEP is, you know, getting yourself an instrument, right? And we've been fairly good at being able to find used or loaner SSP3s. We've kind of run out the string now. We're looking for more. So if you know anybody that has one that's dusty and is dusting off, let us know. I think that Optech will still make them, but I'm not sure when the last time they made one was. Might have been when I bought one 5 years ago. But that might be a barrier for some people, but there's usually a few online. There's one on eBay right now that I think is overpriced, but you know, it does say there's still some out there. So if you are interested, contact either Tom or I. We sometimes are able to shake the trees and find one. There's a few loaners out there. We love it when people are using them. We hate to see these instruments sitting out, not being used. So, okay. I'm going to talk through this, although I think, again, Tom's the right guy to talk about it. So I'll go ahead and go through it a little bit. But But as most of you know, there's been a lot of interest in Betelgeuse because of the dimming in the 2020 observing season. And so obviously there's a real drive for observations. And so here's a sequence that takes you really from 2018 through 2020. And these are from the PEP group. So these are sorted from the PEP group. And they're in the V and the B band. And I think what you're going to notice when you look at it is some pretty nice shapes, some pretty nice data quality, not necessarily a lot of noise. Now, again, also not a lot of observers at the same time. So that's kind of a push to say, you know, hey, can we push this a little more? Can we get a few more observers? Obviously, everyone's still wondering what's going on with Betelgeuse. So please put that on your list of observing targets. If you haven't, it's, you know, you're not going to have any trouble finding it. So take a look at it. A few of the observers have actually started to get queries from professionals. I think Tom is publishing a paper with a professional group on Betelgeuse based on these observations. That's well, here's a few right here that Tom listed in the last conversation. And the idea there was, okay, so what caused this this dimming? And you can see that there's disagreement, which makes things interesting. Some people say dust, some say mass ejection, some say it just changed temperature. All of that is being determined from different methods, spectrum, polarimetry, where you looked at the polarized light, but also straight out photometry, and that's where we come in. So this is real science, and I think most of the people that have gotten into variable star observing like the idea that it's real science. I've always been amazed that you can tell so much from a star just by looking at the change in brightness. I mean, we know their masses because of that. We know, you know, their periods, the you know, just so much, what they're made of, the chemical composition. Just again, I'll do another shout out for Tom. He got tagged to write an article on Sky and Telescope. So you'll see the PEP group represented in Sky and Tel. I have to admit that I've let my subscription lapse, but I might buy it just for this purpose to get this article. Yeah, pretty cool. And again, why? You know, why did Betelgeuse change its brightness? The idea is that there's this chromosphere above the photosphere. It's very hot. And in addition to that, Betelgeuse also has a dust shell. So it has a dust shell as well. And changes in the sizes of these various regions can certainly affect the brightness. So again, lots of work on Betelgeuse. I'm thinking I'll just talk a little bit about it. But if any of you have seen some of the interferometry pictures of Betelgeuse, they can actually see you know, large areas of different brightness. If you do a quick search on the web, you'll see some pictures where they've, through interferometry, shown that, yeah, there actually is things going on where there's certainly regions in the outer atmospheres that are hotter and cooler. And, you know, then you have basically the things churning. The star basically is belching up large amounts of gas from deep inside. And that's where you get this long secondary period. If you look at the light curve on Betelgeuse, you'll see that there's more than one period, that there's both a somewhat regular period and then a secondary period, which is longer. So if you kind of do a spectrum analysis of the data, you can pull out distinctly different periods, even though they're somewhat irregular. So that's kind of, okay, this is what this is kind of a model, and I think it's also from the interferometry. look at that. Can you imagine what it would look like if you were close enough to Betelgeuse to actually see this? You know, you'd see a star that basically had this mottled appearance. Although I'm sure you'd have to wear some pretty heavy duty sunglasses. But really amazing that we can tell from where we are that this is what's going on in the star. So, and really, how do you see the hot spots? It's from polarization. So, you know, polarization is that the light is basically preferentially moving perpendicular to its direction of travel along a certain axis. And so by looking at those different axes that it travels, it works the same way as a Polaroid sunglass, where if the electric field is in one particular direction, you can let it pass. If it's not, you can block it. So you're able, people are able to do photometry using polarizers, and they're able to basically look at a star and map what the difference in brightness is with different polarizations. And that's helped them come up with some of these theories, these convection theories for why Betelgeuse is changing. And again, talking about our parameter space a little bit, this is really ideal for PEP. I mean, this is when Betelgeuse started. I mean, PEP group really got called to do it because we could do really accurate photometry of it. The standard CCD observation techniques saturate. They saturate because the star is so bright. And you can get around that by changing your observing technique, but most people aren't set up to do that easily. And so, again, that's where PEP comes in. We're used to doing bright stars. We do it accurately. This is where we shine. All right. Spectroscopy was also a way that people looked at it. You basically can split a spectral line if you have a high magnetic field. And so apparently in the cool area of the stars, the stellar models show that there's fairly strong electric currents that cause these magnetic fields, and you can actually split the spectral line. So that's another technique. So obviously we're not doing any of that. We're just measuring the brightness, but oftentimes they want to calibrate some of these other readings, like spectroscopy readings. They like the basic photometry to be able to give an absolute value for the brightness. All right. And a little more on Betelgeuse. Again, I think Tom would be the guy to talk more about this. And again, many of you have seen this because you came to the quarterly meetings, so I don't want to spend too much time. So far, what has happened so far this year, I haven't gotten out yet. I'm feeling bad. I saw a clear night. I walked out yesterday. I saw Betelgeuse. I had something to do, and I was kicking myself all night. So if you haven't gotten out and gotten some data on this star, I really encourage you to do so. It's worth it. This is from DSLR observation. So this is from a single lens reflex camera. So this is not PEP data. And there's some more. Usually we get a little more scatter in the DLSR data. For instance, right here, it's kind of disagreeing with the other data. A lot of times DLSR data isn't really transformed. Most of it's untransformed. So it's not necessarily, and there's some other artifacts that come through. So I have to say I struggle to look at DLSR data, and I don't know, there's a lot of noise in that signal. And additional PEP. Okay. All right, daylight photometry. I'm not trying that with the SSP3. I don't think we can do it with the SSP3, but some people can do it with CCDs. So that's kind of neat. All right, so I just want to talk briefly about targets for the fall. Here we go. what I found when I started PEP observing, it was the hardest thing for me was to figure out what to look at. Like, who cares was the big question I would ask myself. And, you know, how did I pick a star? So again, here are some that others are observing. It's nice to be able to compare your data to other people. These are stars that Tom has gotten correspondence with where professionals are interested. And they're within the parameter space. So these are the, you know, if you can't, you know, if you don't have a particular one you want, go ahead and do these. There's some that some of us do on a regular basis, like ROCAS. I like to look at WBOO. But these are ones that Tom's kind of culled down, and since we have limited bandwidth, maybe we could focus our fire and work on these a little bit.
Can I say something?
Yes.
The cool thing about PEP observations is that they are focused on bright stars that are in desperate need of observations, but bright stars can be observed by our observers spectroscopically as well. So for example, while I was, I'm one of the validators for spectra from the Aavso database, there are lots of spectra on Betelgeuse right now. So while you guys are getting photometry, there are others who are observing the same star spectroscopically, and that is calling for a beautiful data set to be analyzed in the future. So perhaps if you don't mind sharing this list of bright targets, or at least you can advise us, we can advise spectroscopists. So there's a nice synergy between the two observing sections.
Now that's right, because by its nature with amateur equipment, you need bright stars for spectroscopy too, right? To get the signal, you're spreading the light out so much. So it seems very synergistic. So actually that's a really good thought in terms of maybe a little more coordination between the two groups of observers. Because I don't know of any of the PEP observers that are doing spectroscopy. And I don't know any of the spectra, and that converse is true too.
Because the other way around, right?
Yeah, that would be interesting, and it certainly gives you a richer data set. All right, yeah, so we'll keep that in mind, maybe a little more coordination. I'll pass that along. Okay.
That'd be awesome.
All right, let's see, what else did I have here? This is old news now, it's from the old thing. So I won't talk much about this, and we'll move on.
Oh, please keep observing Betelgeuse.
Yes,
please.
That, it's right in our parameter space, so there's no reason that, and you don't need a finder chart. We're all set with that. So, okay, I'm going to skip over this stereo. I'm going to skip through this, and we won't go through that. Calibration stars, okay. When we do our transformation observations, and I think Michael talked about this a little bit earlier in the call, we observe red-blue star pairs. They're close together. We generally don't have to correct for extinction if we do them at fairly high altitude because they're so close together. That's why we picked them. But we're working within the group to try to run down some problems with the published magnitudes and colors of some of the pairs. The one that we've used the most and that we feel is the gold standard is the Leo Minor red-blue pair. So if you were only going to do one calibration observation a year, do it in the spring. Do it when you can get Leo Minor high in the sky. And that will give you good transformation coefficients that are consistent with what we're using, other observers are using within PEP. The other list, and if you go to the web page, you'll see a list of other red-blue stars in Aquarius, Pegasus, Andromeda, Perseus. Those we also use, but some of them are under review because we are getting different transformation coefficients when we use those compared to Leo Minor. So like, for instance, if I use Leo Minor get my transformation coefficients. Tom does it, gets his. And then we did that one set of work where we compared our observations on other stars, and we got, just a few millimags different. We feel really comfortable that those are working, that they're doing their job, because my system uses a different telescope. It uses obviously physically different filters. My diode in my SSP3 is different than his. So there's lots of things that are different, and yet we're able to take them out by transformation. And Leo Minor does a great job. The other ones, not so much. Now, on the other hand, the more observations we get of the other ones, the more likely we'll be able to correct the catalog values for them. So if we get enough data for the other pairs, we'll probably publish updated magnitudes and colors, which would be pretty neat for us to do as amateurs. So that's the other thought. But if you haven't done a calibration yet and you're a new observer, and if you're going to do multicolor, if you're just starting out and you want to do V only, visual, the green filter, the V filter only, obviously you don't need transformations for that. Well, I won't say that. You still can take them, but you can start without doing transformations. I don't want anybody to say this stuff's too complicated for me. I don't want to do it. Two things. One, we can make it just as simple as any other observation. And two, we can help you through it. But if you are moving on and you are doing your transformation measurements and calculations, please try the Leo Minor pair. I like doing this just because I like the way the stars look. It's just so neat to see two stars in the sky right next to each other, reasonably close, that one's pretty red, one's pretty blue. It's kind of nice. All right. This is just kind of a thing way back from 1988, where it kind of cast some dispersion on the Aquarius set. So just kind of a note. That's one nice thing about the PEP newsletter. And again, it is published every time the AAVSO newsletter comes out. There's always a PEP section. You can always read that. It's nice too, we list the observations in it, so you kind of know who's looking at what star. If you're not sure, well, who's looking at what, you can go back and look at the last few issues. So pop back and look at the last few issues of the newsletter, and you'll see what stars we're looking at. And so this is just some data from Aquarius observations. The delta V for the claimed was 254. So far measured with a few observers is 294. Stay tuned, but that's too much of an error for transformations. So we'd like that to get smaller. All right. So that's just some general comments Tom had last time on transformations. And again, this is more to give people that maybe haven't been to these meetings an idea of what we did cover. And he said merciful end here, so I'll stop on this. I did want to give one last plug for the accuracy on the SSP3 devices, because sometimes people will look at them and they'll compare them to the fancy CCDs, and all this data reduction, all this software, multiple ensemble stars where they're comparing it to tens of stars in the field. And yet at the end of the day, within our PEP group, we have very strong focus on accuracy, and we have very good agreement between observers. I did a lab test of the linearity of the SSP3 device. So I did it just on the electronics. So forgetting a little bit about the light, I didn't have a way to do it to high precision with a light source, but I certainly was able to put an electrical signal in and do it. And I got a linearity that basically, if you've done any linear fit, you talk about the correlation coefficient, which you'd like to be 1. I got it to be equal to 0.99999. It was less than 0.01%. I've used that in my observations before. Once in a while, you're stuck with a comparison star and a target star that are just so much different in brightness. And that's an error. So if I have a star that's maybe, 100 times brighter than, or even 10 times brighter than my variable star, it's really important that the device be linear. That's what we do when we make measurements. We're subtracting out offset and we're looking at ratios. Absolute accuracy doesn't matter, but repeatability does and linearity does. And I will tell you that the electronics within the SSP3, from a linearity standpoint, are good to around 0.01%, at least in that one sample I had. So when you take your little SSP3 box out and you put it on your telescope, in no way should you feel like these $8,000 or $10,000 cameras somehow are trumping your system. They're not. Throughput, yes. Throughput, they'll swamp you. They'll take readings so fast that your head will spin. But if you're willing to take 15 minutes for a reading, and if you're willing to do that work, you're going to get accuracy that at least has been demonstrated to be the best of the observing methods we currently use. I don't think that'll change. There's nothing inherent in the CCD technology that prevents higher accuracy. I think it's technique and standard data reduction techniques. Others might have different views, but I'm the one that's talking now, so I guess I'll tell them my views. These are things we can kind of argue about. But anyway, all right. Well, I've done a lot of talking. I kind of want to know other questions, so please ask away if you have any.
Hi, this is Mike Hartman.
Oh, hi, Mike.
Well, I'm pretty new to this. As I said, I missed the choice course, unfortunately, but you've caught me up, I know, on some of the aspects that were covered in the course, and I appreciate it. And plus, I've read the BEP manual. Well, let's say I've read it partially, and I think I'm going to need to read it a few more times. It's full of great stuff. The CCD photometry presentations and the study I've done on that, to me, it's a minefield compared with SSP3 observations. But can you please put a frame around this question? Can one expect to achieve useful results from a truly small telescope, 3-inch aperture to 6-inch aperture, with a homegrown photometer rig using a photocell and some electronics, and doing calibrations and doing all the wonderful things that you normally do with an SSP? Can you draw a frame around that question as to whether or not this is worth pursuing?
Okay, so are you thinking of designing and building the photometer yourself?
Yes.
Okay. All right. So as far as the detector goes, you have two choices in my mind. You would either use a photodiode or a photomultiplier tube.
I appreciate that. I appreciate that in advance. My question is more like, I understand that scintillation is a problem that increases with smaller apertures.
Right.
And that this, I imagine, I'm guessing, is the reason we were talking about 8 to 12-inch apertures for photometry. And if that's the case, then it may be a death march to try to develop a 3-inch telescope or 6-inch telescope PEP system.
I think it would, I'll say it's the right way. It wouldn't necessarily, there would be more noise. I consider scintillation to be noise. And so it's, obviously you'll have noisier readings because of that. Your signal will be less because it's less. But do I think it would be useful? Yes, I still think it would be useful. And the reason I say that is you're still going to exceed, in my mind, and I'd have to do I haven't done a calculation on that. So now you've thrown something that's intrigued me enough for me to go out and take a look at it in terms of scintillation. But I still believe you would get accuracy that would be worthwhile. So I would not discourage it at this point. The question would be, a fair question would be, what the drive would be for the smaller scope. You know, there's obviously cost, size, ease of use. I mean, there's a lot of benefits to a smaller scope in that regard. I think, let me get back to you on that because I can't give you a quantified answer right now.
Oh, that's great. I really appreciate any insight you have in that.
Yeah.
Let
me
look.
look.
To me, it's a challenge that I'm interested in, but I don't want to set off on it with nothing but doom at the other end.
Right. You don't want to put all the effort in and run down all the issues with the electronics and the mount and the mechanics and then have the physics of the atmosphere just tell you that you were on a fool's errand, right?
Exactly. Thank you so much.
Fair enough. Let me take a look at that and see. Now you mentioned 3 to 6 inch, okay? So that's a range, right? So the answer might be not so great for 3, but maybe okay for 5 inch. That's the kind of answer you maybe would want, right?
I don't know. I'm interested in the range 3 to 6, and with the notion that if you had something that was useful at the 3-inch aperture, and I see photometry studies being done with refractors that are apertured at 3 to 5 inches, right?
Well, you know, like I said, the scintillation will end up being noise, and you can certainly, by taking more readings, you can compensate for the noise and start to average it out. One of the things that we could maybe do, and I'm just talking out loud. It's not hard for most of us to stop our scopes down to that aperture and use the instruments we have currently, right? So it'd be easy to get empirical data from. Assuming people are willing to put the time in, right?
Well, yeah, sure, but
and I know I'm not going to have a lot of observing time between now and the end of the academic term, but during the winter break, this might be kind of a fun thing to do. You know, after I'm done with my observations for the night, throw the mask on the scope and stop it down to 3 inches and see what I get.
Okay, well, if it's fun, that's important. That's
well, yeah, you know, like it's fun to try to understand what the limitations are, right? Like
exactly.
So, all right. So let me take that under advisement. I'll see if I can find you an answer. I don't have a good one for you.
Well, hopefully it's a question that's crossed the minds of others too, and it will be useful for more than just me and you.
All right. Okay. So any other questions or comments?
I have a question. How many people are we in the Aavso? Like, can you guesstimate a number? How many PEP observers?
I did not go to this annual meeting. Last time I remember there was somewhere, and someone else can pop in. I don't know if this is where, you know, now I'd love it with Stella popped in right now. It would be perfect.
It's 1,400.
Is it 1,400?
Yes.
Okay.
No, 1,400 members of Aavso, but how many of them are PEP observers?
Okay, for PEP we have about a dozen is the number I always use, and there are varying. Some will be active for a while and then step out for a while and then get back in. I'll put myself in that category. Others have done it and have not stopped. But we're within that range. It's roughly a dozen is the number I'd give you. It's actually growing, which is nice. And actually I might be underselling us a little bit. It really depends on, you know, where I draw the line in. Well, okay, if you observe, you know, 5 observations a year, do I count? well, you should count, right? You should count. So if I do that, it's probably a little more like, maybe, up in the maybe 17 range, but a dozen's a good number. And with that, it's surprising how many areas of the world geographically we cover. And it's, I'm amazed, we have a number, let's see, I should count the ones in Europe. 1, 2, 3, then New Zealand's 4, Australia 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, the United States. 16. Okay, I counted 16 just in my head there. All right, those are the ones I know by name. All right, I could answer it that way. I know 16 by name. And Tom's going to probably come back and scream at me for not knowing that answer, but Tom, I'll give you that for now. I think just this year there's been 3 or 4 new ones. So it's surprising and encouraging, heartening that I think some people are grabbing back onto this. I know I find it comfortable that I can actually understand my data. In my life and in my career and what I do, I have to put lots of things into a computer and have the answer come out, and I have to trust it. And even if I've done some verification, with the PEP, the data set's small enough that I can look at it. I can do a sanity check on it, a quality check on it. It's more personal. It's almost like, I know what that data set should have. I can tell whether it's noisy. And I'm under the stars when I do it. I know, oh yeah, that was when those clouds blew by. No wonder their data's noisier then. But I think that's some of the appeal, is that it's like a step up from visual observing, in that from an accuracy standpoint, you're every bit as accurate as anyone else. But you're still close enough to the data, so it maybe has a little bit of both. All right. Well, I am open to any other questions.
Okay, I have one.
Yeah.
Tom pointed out at one time that the I-band filter that's supplied by Optic with the SSP3 is not a standard one. It doesn't match the Johnson-Cousins passband.
Yeah.
And that he had one made, custom made for his instrument.
Yeah, I think he got it from Chroma.
Okay. Well, I've been doing a lot of, I've been pounding the pavement looking at different I-band passbands that are appearing in the literature. And to me, it's very confusing. And
so you're seeing that there's different, that it is
the shape of the passband for the I-band is variable depending on which paper you're reading sometimes.
Right.
To the degree that they even tell you what the passband was for the I-band.
And that becomes problematic.
Very much.
I'll try to give you a little better answer. I find it even more prevalent as you move into the near IR, and then it's almost like a free-for-all. It's like you're wondering.
Well, Tom in the PEP manual describes how the atmospheric extinction in the near IR can vary. The passbands themselves are varying right in front of you. So
right. Absolutely. Right. That's right. The atmospheric passband is not under your control.
Right. Right.
I was heartened once when I read, and I don't know if this is true. I read it in a paper actually, and I really should do some more work on it. But it's I live in Vermont, and sometimes in Vermont when I go out in the winter, I'll do some of my IR stuff with the SSP4. And it might be 15 below zero. Like that would be a good day to do it for a bunch of reasons. And the humidity is so low. And so there was an argument that in the cold winter in the north, you can get less atmospheric moisture than you can get at Mauna Kea in certain cases. So I just thought that was neat. You know, so like on these cold nights when I'm having motivational problems to get outside, that gets me out of bed and into the, it's cold out. It's cold outside. I had to use special grease in my mouth. Anyway, I did it. It started to chatter up. So, so yes. And so how do you transform it? Not, you know, it's not even just how you transform it, because we, at least as a PEP group, could decide on what we do. Like we, you know, we could have our standard. But the trouble is, you look at the catalog values for I and for comparison stars for I, and how do you trust it? You know, what band did they use? What particular filter band did they use? And it is a problem. And I'm going to defer that to Tom. And I think, you know, it would be great to send him a note and ask him to put that on the agenda for the next quarterly meeting. He's talked about it once before, but I mean, you'll get an answer from him sooner than that. He'll be happy to reply. But you know, it is a problem, and especially when you're trying to transform to a standard system, and there's no standard system is what essentially happens. So I'm going to defer that one to Tom because I don't know enough about the details. I do know I do know what you're talking about, but not the level I can give you any answer.
No, thank you. Thank you very much.
Yeah. All right. So, anybody get any recent observations in? I wish I could raise my hand. I haven't for a while. No, okay. So, well, I do encourage you to get out there. I don't know. There's something I know with PEP, it hit my sweet spot of just the right amount. Like I said, I can get my mind around it. I like the accuracy. I can learn the names of 16 people, which works. It's nice. After a while, I get, you know, and for most of you, you know, I may have just met you recently, so welcome aboard. It's certainly a nice community, and I want to get to where it's more than 16. I don't care if I can't remember everybody's name. That'll be all right. That would be a good thing. So, all right. Well, I certainly will stick around as long as necessary to answer any other questions. Happy to do it. And certainly appreciate everybody's interest. So, okay, 1, 2, 3. How many do we have anyway that joined? Was it 5 or so? 1, 2, yeah, about 5. Okay, that's good. All right. And how many people online are still looking or at least thinking of trying to get a hold of an SSP 3 or 5? Anybody still?
I have, yeah, Claudia here. I have an SSP3 that I've got 2 of them actually from 800 years ago. I actually in the early 90s taught at the astronomy department at Columbia, where my students and I would use the SSP3 regularly at the time, which was at the time borderline cutting edge.
Yeah, yeah.
The time has passed. And they've been doing what so much astronomy equipment does so well, which is to stay in the attic gathering dust. I've been doing some cleaning up, and lo and behold, what's in this box here? And untouched in probably 20 plus years. So I've got to also dust off my skills with it. So I'm going to pretend to be starting from scratch to fill in the Swiss cheese holes in my memory and knowledge of their use again. Because I've been doing CCD work like so many others have been doing.
Okay.
But when you said today that the accuracy is a positive aspect, it brought back memories, absolutely. So I'm getting a little bit re-stimulated here. We'll see how the rest of the semester goes. Well, I'm up in Vermont. I'm in Chester, Vermont. So
Oh, okay.
south
Well,
of you,
Yeah, I
probably.
guess you're south. Okay.
Yeah.
Well, so you have the same bad skies.
Oh yeah. Right now they're perfectly beautifully overcast.
Would you like to continue?
Yep. Whoops.
Yes.
Yes.
Yes. Anyway, so I may be putting my little pinky back into the use of the SSP3 again, probably later in the fall, early winter. We'll see. If so, you'll definitely be getting annoyances from me.
Well, that'll work out well.
Yes.
We're certainly very close geographically. So
You're located.
I'm in Shelburne, just south of
Shelburne.
Burlington.
Yep.
Yep. What's nice is that once you're up and running, what's great is if we start to do observations like concurrently, to just do comparisons, data checks, quality checks.
Yeah.
We've reduced some of the variables. We're
Yeah.
closer together. I mean, the local sky conditions are certainly still going to be different, but yeah, wow. That will give us a grand total of 2 PEP observers in Vermont. That would be great.
Yeah. My OTA right now is an old Brandon 94, which is about to be changed up to my 10-inch. I have a 10-inch Schmidt-Newtonian, one of those big needs.
Okay.
They don't make anymore, but they're really nice optically.
I was going to say, yeah, that's true. You could, and a photometer will mount nicely on that.
Yes, it will. Let's see what happens. Give me a month or two to well, it's going to be a month or two before I get a clear sky. Anyway.
But you'll get that winter sky that
winter sky spectacular. Yeah.
Nice transparent but turbulent.
Right. Well, I have to say there's that standard northeastern meteorological pattern, which is that you get the blizzard that goes by, then the temperature drops by 500 degrees or something. It's absolutely frigid, and then the wind quiets down, and then you've got a sweet spot of 1 to 3 days of perfection, very low humidity. Those are worth waiting for.
I know exactly what you mean, and it's like wow.
Yeah.
And then it gets cloudy.
And it's cloudy for another 2 months. Yeah, exactly.
But you're absolutely right. You get and when they're coming, right? You actually know after the snowstorm you're going to get Yeah. Yeah. Well, welcome aboard. And happy everybody could join. Happy you took the time.
Thank you.
Yeah, we'll take care. I think I can go ahead and stop the meeting, but I'm fine to stick if anyone has any additional questions. I don't think they're going to kick us off the channel, but if not.
Well, I have to say thanks to you and to all the participants. I learned a lot, and it's been a great resource for me.
Yes, thanks very much.
All right.
Appreciate it.
Yeah. Well, clear skies.
Okay. Take care.
Good luck. All right. Take care. Bye-bye.
Bye, everybody.
Thanks, Jim. Thank you, Jim. Bye.
Yeah, you're very welcome.
Bye.
Phone call completed.
All right. So.